This is Fine Suspension. I'm Peter Larsen from Loudsoft. First, I want to design a spider using this template. We are going to use the given dimensions, except two things. We would like a little more landing area close to the voice coil, so we would use the wave length, and then also we need a little more landing area, so 68 millimeters will do. Next, we need to define the area close to the voice coil that will be fixed by glue, so we set ID and select this green line here. And the same thing for the outside. Here, this will be fixed to the frame. Now we're ready to calculate, and after pressing the button, we see the deformed spider in steps for positive and negative displacement. And the spider will be shown when this is done in the maximum up and down displacement for the applied force. After calculation, we see the stiffness curve, kmx, in the right window. This curve is U-shaped and it has a nonlinearity because there's a mirror line which does not overlap the curve. Instead, we can show the inverse curve, which is the compliance, and this has a maximum at 0, and the value is displayed. The green part is for 75% of this compliance, and that is defined by IC 62458. Finally, we can show the same data as the force versus deflection curve. This curve follows the straight blue line for small x values, but at large excursions the nonlinearity is quite obvious. Going back to the KMS curve, we notice that the positive up movement is larger than the negative down movement. Let's try and do something about that. Let's try increasing this height while decreasing this one and increasing this radius, and calculate. This spider is now symmetric up to plus and minus 8 millimeters displacement. Now, let us design a half roll surround based on template 1. Having defined the material as typical rubber Shaw 60, we only need to define the cone and frame attachments. Now we define the inner flange as the green line and the outer flange that is going to be glued to the frame. And we start the calculation. The resulting KMS curve is nice and almost flat up to plus or minus 6 millimeters, but it's not symmetrical. First, we may decrease this overhang here to 0.2 millimeters. Zooming in, we notice that the surround flange actually is bending slightly at maximum excursion. Assuming the cone edge is stiff, we may fix the upper side of this flange, like here. The calculated KMS curve is now perfectly symmetrical, having a range of plus or minus 6.5 millimeters with good linearity defined by the yellow range. The yellow range is defined by the compliance being within 75% of maximum. In case you cannot design a suitable spider from the 5 templates, you can always import your own DXF file, and this can be made in any CAD system. You can even export DXF files from the templates and change it to your own special geometry. This is the end of the demo. Thank you for listening.